Hi everyone. So in the previous video we were talking about the idea of acids and bases. We did look at the definition of acid. We know the names of common acids, which are hydrochloric, sulfuric and nitric. We know that SO4 is sulfate ion and NO3 minus is nitrate ion. We never change these formulas. We know that acids can be identified using litmus paper, a blue litmus paper particularly, or we can identify it using the universal indicator, which shows a color of red for strong acids and yellow for weak acids. Orange means somewhere between strong and weak, but we do know that red and yellow are the common colors that we need to remember. A pH meter is an electrical apparatus that we might want to use for more precise understanding of whether a solution is acidic or not. So pH meter is more precise, more accurate, and it gives us some mathematical value of what is the pH of a solution. And if the pH turns out to be below 7, it's obviously an acid. Right now we're going to be talking about the reactions of acids. So the first one is they react with metals. Now we know that metals obviously make positive charges. So metals are the ones which make positive charges. We're going to use this idea later while we are creating the equations. So remember the fact, for example, when HCl was reacting with sodium metal, let's suppose, HCl has H plus and Cl minus charges because HCl is obviously an acid. It's going to give out the H plus ions. So what happens is that sodium, being a metal, develops a plus charge and it decides to go for the chloride. So they decide to make a pair and they end up making NaCl. What happens to the H? The H remains alone. So this is what happens to the H, and ultimately we end up having H2, which is the hydrogen gas. So we never write H only, we write H2. In order to balance that, we have two hydrogens over here and only one hydrogen on the left hand side. So we can balance it by adding a 2 at the front of it, then a 2 at the front of the sodium and NaCl as well. So it's a balanced equation, but at the end of the day we get Na with Cl, which is sodium chloride. So this is sodium chloride and H2 gas. Let's try out one more example. For example, we had H2SO4 and we had, let's suppose, copper, or you can say, let's suppose, any common metal is potassium. What happens is that H2SO4 has H plus ions. We can see 2 H plus ions. So there are 2 H plus ions, and sulfate has a charge of -2. Potassium is a metal. Metal always make positive charges. So potassium should go for the sulfate because only a plus charge can make a compound with a minus charge. So potassium makes a plus, sulfate is a minus. So they end up making K2SO4 because the formula for potassium sulfate is K2SO4 because of the charge swapping. And what happens to the H? We write the H as a separate product, which is H2SO4. So ultimately the hydrogen is separated and what we get is the H2SO4. Similarly, let's try out one more example. Let's suppose I have zinc with me and I have HNO3. HNO3 means H has a +1 charge and NO3 has a minus charge. Again, zinc is a metal. What we'll get is we'll get zinc reacting with the NO3 to make zinc nitrate. NO3 means nitrate, so zinc, when it's with NO3, it makes nitrate. So what we get is we get ZnNO3, which has a chemical formula of ZnNO3 twice, because Zn has a charge of +2, NO3 has a charge of -1. Formula making is something that we should know, and then ultimately we separate the hydrogen as H2. So again, at the end of the day, Zn decides to go with the NO3 making zinc nitrate. This is zinc nitrate, and the H decides to separate itself because it doesn't have a partner. So it ends up like this, and we get hydrogen gas over here. So whenever acids react with metals, they give out hydrogen gas. One thing is very clear: whenever you add acid into a pure metal, it's going to give you hydrogen gas. Let's try out one more example of what other kind of reactions we have with acids. So when acids react with metal carbonates. Now what's a metal carbonate is a question. A metal carbonate is a metal which has a CO3 charge with it. So we can be having a metal plus CO3 with a charge of -2. A metal could be any metal with a charge of CO3 -2. So it can be having sodium carbonate, we could be having potassium carbonate, or you can say maybe magnesium carbonate. We can be having calcium carbonate, let's suppose zinc carbonate, or for the sake of it copper carbonate. These are all metal carbonates with the charges of metal and non-metal, which is carbonate obviously. So if a plus charge of a metal is with a carbonate, carbonate means CO3 -2. So that basically means metal carbonate. Now whenever acids react with a metal carbonate, for example, let's suppose I'm talking about HCl, and HCl wants to react with the sodium carbonate. Remember one thing, I'm deleting this part for simplicity. Remember one thing, we can make things easier by breaking the carbonate into its component parts. So whenever you see a carbonate written, whenever you see CO3 written, my suggestion is do this extra working. Break it down into CO2 and O. CO3 breaks down into a CO2 and O. Now you know that sodium is a metal with a charge of plus, carbon dioxide is a pure molecule, and O oxygen has a charge of -2. Similarly, HCl has a charge of plus on the H and Cl has a minus charge. Now you can change the partners. So Na must go for the Cl. So Na would be going for the Cl like this, and it will make NaCl. H will go for the O and make water. And CO2 will be released as a product, totally separate product. So these are the three products that we receive. We receive a salt, which is sodium chloride in this case, carbon dioxide and water. Let's try out one more example. We have calcium carbonate, which has calcium with obviously, CO3 part in it. So calcium is the positive charge, CO3 is the minus charge. With an acid, for example, let's take sulfuric acid over here. Now what happens is that since you see a CO3, break it down into a CO2 and oxygen. CO2 is a gas, so it doesn't have a charge, but oxygen has a -2 charge. Calcium is a group 2 element with a +2 charge. Sulfuric acid has H with a positive charge and sulfate with a -2 charge. Let's compare and combine the products. Calcium should go with the sulfate, so it makes CaSO4. H goes with the O, so it makes H2O, and carbon dioxide is a totally separate product, so you get carbon dioxide. So whenever acids react with metal carbonates, they give out carbon dioxide gas. So they give out carbon dioxide gas. For the sake of it, let's try one more example. Hypothetically, I am making, let's suppose, copper carbonate, which is CuCO3, to be reacting with, let's suppose, nitric acid, HNO3. Now again, let's do the same rough work. CO3 breaks down into two things, CO2 and O. This is what you have to do all the time. You can just break down the CO3 into a CO2 part, which is a molecule, and oxygen with a charge of -2. Oxygen is obviously it's 1O, but oxygen always has a charge of -2. If you remember the periodic table, oxygen is in group 6, so it has a charge of -2. Copper is a metal, it has a charge of 2+. Nitric acid is H+ and NO3-. Combining the partners, we get copper with a nitrate. So Cu should go for the NO3. CuNO3 twice is the chemical formula, because obviously if you remember, copper has a charge of 2+, NO3 has a charge of -1. Copper gives the 2 to the NO3. So charges will obviously swap up. So you get CuNO3 twice for copper nitrate. This is the chemical formula. If you can memorize this, that would be amazing. What happens to this part? H goes with the O and makes water. Never write OH, obviously. It's not like H is going to O, so it should make HO. It makes H2O. They combine and create a proper formula. So it's H2O. What else do we get? We get carbon dioxide because it's right over here. So the product is carbon dioxide gas all the time. It's water. And obviously a salt that depends on the base, and obviously the metal carbonate, obviously, and the acid. So Na was coming from the metal carbonate, and the Cl came from the acid. Similarly, calcium came from the metallic carbonate, and SO4 came from the acid. So obviously a salt is it's like a product of acid and base combined. So remember this fact over here. So acids react with metals to make hydrogen gas, and they react with metal carbonate to give out carbon dioxide gas. In the next video, we'll be talking about the idea of their reaction with bases, particularly neutralization. So we'll catch up in the next video.